Well, welcome everyone, first of all. Thank you for joining. And while everybody is still joining, let me tell a couple of words about the FHIR meetups and what's it all about. So FHIR meetups are for all of us, like health IT and medtech engineers, innovators, entrepreneurs, to get together and discuss the latest news about FHIR, challenges we are facing, and solutions for these challenges. This is not the first FHIR meetup we are organizing. In fact, I think Nikolay just recalled that's the 8th FHIR meetup. And if anybody interested, there are recordings of previous FHIR meetups. You can find them at health-samurai.io/FHIR meetups. There is also a communication channel to connect to organizers at the FHIR developers chat at chat.phir.org. So if you want to connect to organizers, maybe propose a topic, propose a speaker, please do this. Also, we will definitely be sending the feedback form to collect the feedback about this meetup, and there will be a question about topics for the future meetups. Try to run this FHIR meetups as a very open initiative, so you might as well be the next speaker of our FHIR meetup. Again, everybody, welcome. Please reach out, and again, thank you for joining this meetup. And speaking of which, so today's topic is FHIR at scale. FHIR is getting real, and more data is exchanged and stored in the FHIR format. And of course, we are all facing challenges with scaling and performance at scale. And that's pretty much the topic of today meetup. Meetup is organized as 4 lightning presentations. Each speaker will have 15 minutes. There will be a 5-minute Q&A session at the end of each presentation. So please get your questions ready. You can just message this questions to the Zoom chat, and speakers will be able to pick it up from there. And at the end of all 4 presentations, we're going to try to organize a roundtable for around 1 hour, where everybody will be able to speak and participate as well. So let's start with the first speaker. Let me introduce Nikolay. He's one of our often speakers, repeat offenders. Let me say it this way. He is CTO and founder of Health Samurai. And Nikolay, please introduce your presentation and start.
Thank you, Pavel. Let me share my screen. So I did experiment. So can you see my screen?
Yes.
So it's in Figma. Okay, so I'm Nikolay. I'm CTO of Health Samurai. So the Health Samurai is a FHIR company. So we exist because of FHIR. And we are crafting the FHIR backend to build what we call FHIR first application, FHIR first systems. And yeah, as Pavel said, FHIR getting real, and we really challenge it with all this performance and scaling stuff. So last Dev Days, I did the presentation. Video not yet available, but the link to the slides is here. So there are more details. And today I want to share kind of a few thoughts and ideas about the scale and performance. So the first of all, when we starting talking about the scale, a lot of data and high load, I really scared because we are ordinary engineers, so we're living at the top of the iceberg. So we're here. And the extreme complexity below. So if we look into the JVM, if we look into the Linux, into the Postgres, if we try to get at the limits of these technologies, at the limits of the hardware, So things becoming really difficult and a lot of details start playing, and there is no way to one brain to comprehend all this stuff. So, and in general, it's hard to solve, but that's nice that for specific situation, you can always solve. So the first truth, my truth about the high load FHIR or FHIR at scale, that you need people to make it work. So you need smart professionals to make it work. If you compare, let's follow the analogy with a car. So you may have a car with a garage, you need just gas station, and but if you going to just limits, if you want to be like Formula One, then you really need the people. Then you really need to care about details, and these people should be professionals. And my belief that without this team, such high load system will never work. So be prepared. There is no silver bullet. There is no way to buy something which is fit all your needs and will work with a large amount of data, with a high load and all this stuff. So be prepared. It's a, yeah, and we are coming to that scale and the performance. It's a space of trade-offs. That it means that you could not get all the features and all the properties you want. So yeah, you should choose between options, because if you choose one option, you're losing another. And the main question is what you're going to trade off. So as example, probably all you know the CAP theorem, so which is a theoretical trade-off where you can only pick specific combination, but not all of them. And there are much more other trade-offs here. So, and the question is, yes, what you're gonna trade off? And this choice should be conscious. So, because it really depends what your system, what your application doing. There is no way to create the ideal system which will fit all the needs. So, and here just again, following this analogy, maybe if you're in an old town traffic, so the small car, small city car is better fit than the bolide for you. And it's very important that you could not optimize in general. You can always optimize only for your specific scenarios. And another truth that you should look for constraints, because constraints is the foundation, is a base for your optimization. If you can put some constraints, if you can choose specific way, then you can build very interesting implementation, then you can optimize. So the first, search for the constraints for your system, understand nature of your application, and then optimize. And we as implementers challenging, our goal is to provide you with the pieces, with the parts, so you can solve your specific scenarios in an efficient way. Okay, and we're gonna talk about trade-offs. I mark it as like T. So the first trade-off we did, so we are building the FHIR backend. It's not just storage with a teeny API. So we expect that people are gonna build the whole system on it so that they have control over the whole data inside. So we were always focused on the database, and internally, kind of 5 years ago, we introduced the storage format, which is slightly different than the FHIR JSON. Okay, I forget. So the modern databases, FHIR doesn't very well fit classical relational databases, but the modern relational databases have a support for JSON. And this is nice that SQL standard has a support for JSON. And the first trade-off that I propose to introduce, it's a FHIR storage format. It's a database-friendly format to store data in database. So it just do few transformation. It provide us more structured references. It provide us first-class extensions because we want to access these elements. And probably you can fix the polymorphic, which is a mistakenly done in a wrong way in the FHIR JSON format. So if you go this way and make your JSON representation more database friendly, what the trade-off? So now you have to transform. Now you have to transform on the fly when you're loading to the database and getting data from the database. And that's so we did it, and this is quite big trade-off. So, but we did it, and we're gonna kind of share it with the community. So the first attempt was by SQL on FHIR specification, which was written by Ryan Brush. It was mostly for analytical load, but we are working now on what we call the ZenFHIR storage format and the open source tooling around it, which will provide the conversion, validation data in database friendly format. And in this presentation, this is a link to the GitHub repo. It's a part of more bigger ecosystem, which we call Zenlang, but this is not the topic of this talk. But this is the first trade-off. Okay, so sometimes you have to do some conversions to make it efficient, to make it more convenient. Okay, I can probably explain that if you keep this, for example, reference string in database, you should always parse or make other tricks so to make it work, and it's not going to be efficient. That's why we're trying to make it more database friendly. Okay, the trade-off two, it's import, and a few thoughts about this. So when you want to load a lot of data into your FHIR server or FHIR database, so you want to do a lot of things. In our case, we even have to do the transform. So you want to validate the schemas or profiles, references, terminology. So you want to do this load quickly. So you want to load all your available resources. And here is my experiments. For example, I analyzed just ordinary load with a transaction bundle, and we see like 5K resource per second load for all of the servers, but that's too slow. It's on average hardware with the same database, so this comparable. It's too slow, but let's play this trade-off game. So if we look into the bulk import, so everybody knows the trick for the database, maybe not everybody, but the DBAs knows that sometimes it's faster to drop indexes, load data, and recreate the indexes than just load data with indexes, because yeah, it's a batch creation of indexes on all of the data, maybe much more efficient. And so we want to do several actions, and here is the idea of amortization, so amortize, so when we can pay the price later. And in this case, for example, we can drop indexes, we can validate data ahead, transform them ahead, split it into small pages, so we can create kind of more homogenic load. Okay, and with all these tricks, so we can get like 200K resources per second. It's more than one order of magnitude faster. But then, yes, you have to validate and re-index. And here is the idea which is coming from this when you try to split this big operation into parts, that probably FHIR needs the asynchronous validation. So when you can load data and validate it later in a synchronous way, existing data, this is also valuable when you change your profiles. Let's say you already stored data, but you want to update your profiles. So now you're not sure that all of your data match these profiles again, and you need this asynchronous validation. So in 8box, we have this small RPC method, which is quite smart with a lot of attributes where you can run the validation against list of profiles asynchronously on existing data. Yeah, but the general idea is that we can split it into the pieces, provide you control over each piece, and then in your specific case, for example, dropping indexes means a stop the world. Yes, your system will not work during this, but you can load data much faster if you drop indexes. If it's possible for your system to go down like for 1 hour or something like this in the night, okay, you can do this and load it faster. If it's not, then, for example, we have other ways of load when we're validating on fly and doing stuff, but they are much slower. And that's trade-offs I'm talking about. Okay, another trade-off is a search. So the FHIR search is full of trade-offs because the databases behind the FHIR search is full of trade-offs. So it's said, but databases are not perfect. They are not ideal. They're not good in several things, which we expect they're good. So they're not good in joins. They're not good in sorting. They're not good in index composition. So, and there is one empirical truth. If you want to get the most of your performance, you should hit only one index. Your request should hit one index. Then you can get these milliseconds. Otherwise, it's getting much slower. And that's because, yes, the index is a way to access specific data in a most efficient way. And that's sadly, that's not yet invented, but indexes are not combined. In the FHIR specification, we see that we have parameters which we can mix in different combination, but this stopped working at scale. So yeah, so if we hit one index, yeah, I can show you the results, something like this. Yeah, you can get this milliseconds for the request or for the identifier. But if you start mixing, then it just stopped working. So if you try, let's say, so you have one criteria and you have another criteria, everything worked fine if one of your criteria is very selective. So the database understand that you're gonna just pick like dozen of rows and then do other filter. That works. And in most of cases, this is a very nice case because in FHIR, all of resources, or most of resources are around the patient. And for example, filter by patient may become very selective filter. And we proved this with our partners, Innovator. We did benchmarks on 10 terabytes database that if you provide, for example, the patient parameter, then you can provide other parameters in any combination, and it's going to be efficient. And this is my idea that the FHIR standard should help us to constrain for the loaded servers, add the more information about the search parameters in the combination. And for example, we can introduce something like required parameter. So if you provided the required parameter, then you can use other parameter. If it's not provided, it just doesn't work. So another trick which can be used, most of databases support multi-column indexes or functional indexes when you can use multiple columns in one index. So for example, yeah, in case of observation, we want to search by code and date. If we always use these two parameters, we can create one by3 index and get here we see that these ones are using two indexes, one index for code and one index for date. And this combination is bad for database because it could not pick the main index, and it should kind of merge indexes and find the intersection. But you can create the multi-column index, and then you hit one index, and again you get this tens of milliseconds. So it works. But we cannot index everything this way, yes, because the number of combinations is much bigger than the number of your parameters. And again, we're getting to this proposal to introduce into the FHIR specification or on your server somehow to describe that specific combination of parameters or some if required parameter is provided. So we need the language to describe more constraints on our server with a lot of data. As well, the sorting, the databases are bad with the sorting, especially with the sorting plus paging. And I don't think, I'm not big fan that in FHIR the sorting parameters are mixed with the filter parameters. I think we should separate them, or at least say that these parameters are available for sorting. Only this parameter is available for sorting because we build the battery index, so it can be efficient. Otherwise, it doesn't. So, for example, like a couple of years ago, we proposed, and the FHIR spec introduced this idea of the turn off the total parameter. So you can set the parameter total to none or estimated and turn off the calculating the total. I told it many times that sometimes calculation of the total may be much more expensive than getting data. And on real servers, that's not going to work really at all. And another idea that we want to introduce the parameter, it's already working in 8box, and so the timeout. So you can say that I'm sending this query if it's timeout exceeded. So then please just drop this query. And a more sophisticated way, probably we can calculate this timeout parameter in some dynamic way, because it's quite easy to kind of hang your database. Let's say you have 100 CPU on your database or 10 CPU on your database, and you have one slow request, which takes like 10 seconds. Yes. If you just repeat this slow request, the times, which is equal to the number of your CPU, so your database is done. So it's a completely denial of service. So that's why we need some additional handles to work on it, that not every request may be successful, so that timeout may exceed, or if user can't provide timeout, or if it's important for the user to wait slightly longer, so this underscore timeout parameter can be introduced. Okay. Another thing where database are not good, it's joining. So on real huge table, joining just doesn't work in some as efficient as users expect. Yes, if you have kind of huge table, it just doesn't work. So all the DBAs do denormalization. So they put these filters from different tables into one table, creating this denormalized table, again, build multi-column index, and everything start working. Yes, and we need some tools to say some language again, so to express that on our server, only these chained params are optimized, and you can use it. So that's the idea. Yes, that's getting back to the standard that we need more constraints. We need a language to describe more constraints on search. Okay, and that's all. That's all I draw. Okay, I'm open to the question. Thank you for attention.
Thank you, Nikolay. Questions, please post them into the chat. So Vadim is asking, what is returned when the timeout is reached?
The HTTP code for that, I don't remember exactly it. So which may contain that, I know. Yeah, it's not successful. It's not 500, yes, but 503 or 509. So some information that, yeah, it's out of time limit.
Yeah, the codes are proposed in the chat as well. 504, 408. Not gonna vote for this. Extensions are using, Ilya Bida is asking, extensions are using the slice technique. So when you create an extension, you define a slice. First class extensions are a great thing. What do you think about first class slices? It will be much easier to create indexes for MRN, medical record number, if it's moved from identifier array to the top level.
Yes, guys, for the sequel on FHIR, there were some experiments. They was done not on identifier, but they were done on coding, where the name of the system become the key in an element. So you may say code.lying.something. Yeah. So it's possible, but it's a matter of design. Yes, and so we introduced this very simple transformation, and it's really hard to implement. So that's my opinion. So potentially, yes, it's possible. So we can discuss. There are a lot of arrays and vectors collections in FHIR, which sometimes a specific situation work as a map with a key value, like identifier, passport, SSN, something like this. The same about the coding. So we discussed this idea, but I'm not sure that anybody implemented it. But yeah, so you can go to this. Here is a link to GitHub repo and create an issue. Let's discuss it. But the transformation is hard, and we spend like a couple of weeks to make it efficient. So freaking the code and make it fast on JVM.
Ahmed is asking, in a world where you do massive imports, is it possible to do reference checks? For instance, for dangling resource references, how does it work when you do multi-page imports? Is it possible to do reference checks?
Yes, so it's possible, for example, with async validation, as I said. So there is a best practice from DBA, yes? So in most of databases have what's called foreign keys to create this constraints that you're referencing existing record. But most of high-load DBAs never use it. So this is because there are some scenarios when, first of all, this is a what's called a trigger with implicit behavior, and which may have a lot of performance impact. The second, sometimes there's a situation when you want to load invalid data and then make them valid later, and this usually happens during something like bulk imports. And the response to this, I think, it's to create the async validation operation, so you can load data and then you can validate. Another option which we discussed with our partners, it's create like a staging area. So you can initially load everything into staging area, validate, and then in one transaction move to the main resource table. So something like this. Otherwise, it will be quite expensive. Probably if you're loading everything, so you can think and on a preparation phase for the loading, maybe you can do some basic validations. But again, so it depends on your system, on constraints which we could, on your scenarios and constraints we can use to optimize this scenario.
Thank you, Nikolay. I think we're at the time for your talk. So let's keep other questions for Nikolay for the round table conversation. And let me introduce the next speaker and presenter, Vivian Neilley with Google. She's a product manager with Google. Vivian, please introduce your talk. It's all yours.
Awesome, thank you. So, hi all, I'm Vivian Neilley. I'm a product manager at Google. Let me pull up my slides. Can everyone see them? Cool. So I'll be talking about some of the streaming FHIR at scale issues. I've done kind of a lot of work at testing and advocacy for better reporting on FHIR, specifically managed FHIR servers, but kind of any of the FHIR servers, reporting on their performance. I think this is kind of a gap in the market that we have where a lot of folks are trying to either do a use case that requires very low latency or very high, huge amounts of data or things like that, and having a better understanding of which servers are optimized for low latency, high throughput, versus which servers can scale to, petabytes of data is really helpful. And so I think that's kind of, that's what I've done a lot of my previous looking into. I'll talk a little bit today about kind of the streaming FHIR at scale requirements, and a little bit of this is kind of a shout out to FAST. So for those who work or attend any of the FAST meetings, they're basically trying to solve some of the problems that we're going to talk about today. I love kind of this slide because it talks about why this is such a critical issue. Specifically number 4, in terms of we are expecting a huge uptick in the amount of FHIR we see in the wild. And right now, there isn't a ton, just from my own experience, we don't have a ton of people coming to us and saying, here's a bunch of FHIR data that we, we need to bring in, or here's streaming FHIR data. until the EHRs really implement their FHIR endpoints more holistically and specifically start doing real-time of FHIR endpoints. This is when we're going to hit a huge need for streaming FHIR at scale. And so right now, really most of the streaming FHIR at scale we see is coming from EHRs, and I'll talk a little bit about what that means. Just for background, I said I work at Google. My expertise is in Google's healthcare API. So just for overview of where I'm kind of coming from, the healthcare API that we own is a managed service. So essentially, we provide the endpoint and we take care of both the server, the indexing, and the database. I kind of joke, I threw in the CAP theorem because Nikolay mentioned that as a trade-off, but we actually run it on Spanner, which there is a white paper out there about how Spanner broke the CAP theorem. So I kind of appreciated that comment because some of the trade-offs you don't actually have to make, and this is one of the reasons we're able to have such like a scalable, globally consistent database and get to the point we need for some of the numbers I'm going to talk about. So just to put that in perspective of what a managed FHIR server looks like versus some of the open source software, when you look at a cloud managed service or a managed FHIR offering, we are in that highlighted bar. So really what this means is we're taking care of almost all of the infrastructure and underlying configurations of the server, of the database, of the indexing, of all the things that I had mentioned previously. There's some trade-offs with doing this. So in an open source world, if you want to go faster, you can just throw more infrastructure at the problem. And that's not always entirely true. There's some kind of caveats with the database and things like that. But in general, more VMs means more throughput. But that also means more money. And so one of the things that's a good, kind of a trade-off, as we were talking about with managed offerings, is you can go as fast as they will let you for the same amount of price. However, you are beheld to as fast as they will let you. And so this is why I talk a lot about some of the performance implications that we have, where if we're going to have managed FHIR offerings and not be as transparent as possible about the limitations of the speed, the performance, the scale, the throughput, et cetera, it's going to be really hard for people to kind of put use cases and start building applications and solutions on top of the FHIR offerings because they have no idea when they're going to hit the limitations of a managed offering. And so there's kind of some trade-offs of you might be able to do it cheaper, faster on a management, but there is a little bit of, behind the curtain where a lot of the managed offerings do not have limitations and performance metrics published. So that kind of leads me to the bulk of my talk, which is really where is streaming data to FHIR coming today? As I mentioned, FHIR is not really in the wild as much as streaming FHIR specifically is not really in the wild yet. We see most of our customers coming to us with HL7 and saying we want to convert our HL7 to FHIR, which is probably the most common thing that specifically providers are trying to do today. The numbers of what this actually looks like, and this is the huge caveat here, is this is super back of the napkin math. So I have 5 million HL7 messages per day. That can be wildly up or wildly down depending on number of trigger types they have, number of hospital systems they have, number of bed types they have. You can turn on and off noisy streams. So for example, nursing HL7 is an extremely noisy HL7 feed. And so it really depends, but I kind of like the 5 million as a pretty large implementation, but not the largest I've ever seen. And we take what we would see 5 million messages per day turning into is about one of those messages becomes 20 FHIR resources. And so we would expect around 100 messages a second at peak. And so 100 messages becomes, I have 200 bundles, that's actually an error. 100 messages becomes 100 bundles when you convert it from HL7 to FHIR, as one HL7 message is essentially one bundle of 20 resources. What this really looks like is you need a server who can scale to meet 20 FHIR resources per second. Because even if it's a bundle, the server still has to operate on each of the individual resource. It's kind of a multi-operation. And so essentially, if you are trying to map your data from HL7 at the EMR to FHIR, we kind of say ask for around 2,000 FHIR resources per second. And there's some caveats there that I'll talk about in a second. But just to kind of high level put it together, if you're streaming that amount of data in, that ends up being around 75 terabytes a year. And so earlier when I was talking about the trade-offs of having high throughput and being able to really scale to meet the streaming needs, if you start doing that year over year, it can burden the server where you're at 150 terabytes by the second year and still perhaps streaming in the 2,000 resources a second. And so this is kind of why the scale problem gets accelerated significantly as we go forward, because a lot of people are kind of at the early implementations of FHIR where there isn't just huge FHIR data lakes lying around. But I suspect we will end up getting there in a couple of years. And so thinking about how we can solve some of those trade-offs for huge sizes with high throughput is kind of a really interesting problem and a really interesting engineering conundrum that we have. And so the long kind of, this is a view of all of the CRUD operations that you would need for streaming HL7 to FHIR. You could do mostly creates for this or kind of execute bundles on this one. The issue that I talk about a lot is this is a very narrow-sighted look at the problem. And what I mean by that is, okay, great, 2,000 FHIR resources a second. That actually might not be that bad. But the truth is you need far more than 2,000 FHIR resources per second, because what happens when you are creating or transforming HL7 to FHIR is you end up with transactions. And so what that actually looks like is you could get an ADT, so an HL7 message that has John Smith, and then you'll get another HL7 message that has John Smith. And when running the HL7 to FHIR pipeline, you actually end up with two John Smiths because all you're doing is a simple conversion. And what actually needs to happen to be able to make it make sense is you need to reconcile those pieces of information. And so not only do you have to convert all the HL7 feeds to FHIR, you then have to do some upsert logic to be able to build out a single patient record instead of just having lots of patient records or two different encounter records that really should just be a start and an end time. And so beyond just the 2,000 creates that have to happen, you now have to do search operations and update operations in kind of a complex logic, which means you may or may not be perhaps doubling the load on the server just to make sure that you are streaming in accurate information into kind of the correct FHIR format, not just those transactions of FHIRs in various different resources. And so you end up actually using the whole kind of gamut of CRUD operations when thinking about streaming HL7 data to FHIR. And this is where the scale implications come really front and center, because a lot of servers can scale for the easy CRUD operations, but the second you start adding things like search into the mix and adding the subscriptions into the mix, because you have to notify when to run a reconciliation pipeline, that is when the burden on the server becomes a lot more difficult, because search inherently is going to take more compute than a create operation. And so all of this put together actually equals a lot more load than just the simple back of the napkin math I was talking about. And I think one of the other things that I like to bring out is the fact that just HL7 and FHIR streaming is, yes, the most common that we see, but a lot of organizations want to stream other data into the pipeline. So for example, we're seeing a lot more interest in device data and DICOM data. You might end up having multiple different sources feeding a single FHIR system. So you're now kind of adding additional ingest sources to a single FHIR server, and furthering the chaos that ensues. The second thing I talk about when I talk a lot about the scale of the system is oftentimes the server is run on a transactional database. So for example, our healthcare API, as I mentioned, runs on Spanner, transactional database. Once an organization has a FHIR database, they often want to do analytics on top of it, which means you are kind of causing contention between the applications that need as much compute as possible because they are production applications, and how do you allow for that compute to not compete with the compute that you need for analytics and training of models and all the fun that kind of the data science team wants to do on top of FHIR. And so we actually split out our FHIR server also streams to a SQL on FHIR in a separate OLAP database so that we don't have that contention. But I will say we do see that when it is kind of an open source FHIR server where your data scientists might actually be kind of stealing some of the compute from the applications, the transactions that you need to be streaming data in, for example. And so then the final other thing I'll talk about is this is all assuming that there is a single monolithic FHIR server. Right now in the market, that is actually kind of a best practice because of the referential integrity that we have, where how do you break up multiple different resources, for example. So I think there was a message in about DICOM and how DICOM can kind of stand on its own for a resource, and we don't have that capability. Right now, since it is a monolithic, we are facing a lot of these scale issues. This is why NoSQL grew so significantly, is they've kind of figured out how to better federate a lot of this. And so I have a hint as to what's coming, and we'll talk at the roundtable about it. But one of my biggest considerations is the fact that a monolithic environment, it inherently is never going to be the best way to scale. Is there questions? I can't see the.
Yeah, there is quite a bit of interest around merge, which you mentioned, like merging of different patient records when they come together. Yeah, can you maybe give more details how you handle this? Is it like fully automated? And
yeah, we have a product offering to do the upsert merge logic. It's interesting because the best way to describe it is an HL7 feed is like as if you tried to look at your bank statement by looking at each transaction. So I took out $2 and then got paid and then took out 30 cents. And you tried to figure out exactly how much money you had based on all of those transactions. What you really want to do is get the summary. And that's what our merge logic does, where it will take all the HL7 transactions, they're admitted at this time and discharged at this time, and merge those together to create the period start end timestamp array. That's a lot of logic though, because you can think about it's not just patients that need to be merged. It's actually also encounters. There's allergies that need to be merged. Sometimes source systems will send snapshots of allergies, or they'll just send updated allergies. And so you have to think about not only each resource, but each field, and how exactly it should be appended, if it should be overwritten. There's kind of lots of nuances for the wide breadth that FHIR data covers. We do have a product offering for it, but it's actually something in the market, like just transparently, we don't see solved that often. I think the fact we have a product for it is pretty unique to us. I haven't seen a ton of FHIR merge or upsert logic out of the box.
Thank you. There is a question from Josh. Thanks, Vivian. I'd love to learn more about subscriptions. For instance, what use cases are driving adoption, and what style of subscriptions are you focused on? R4, R5, backport, or something else?
Yeah, so subscriptions are like my favorite topic, and I think Josh is on, so he can talk about topic-based subscriptions, which is probably, when we talk about scale, topic-based subscriptions are going to be the best way to scale, because you can subscribe to what the use case that you're interested in. So perhaps you're a scheduling app and you're only interested in when admits happen, but you don't need to know about the observations. So topic-based subscriptions for R5 and R4B is really interesting, and I think probably will help a lot of these scale issues. Right now in R4, and what US Core uses is like a subscription for everything. So whenever any update happens to a FHIR resource, you send off a notification. That's what we currently support, and it's very noisy. And it means that you kind of have to tease through the subscriptions and understand why there was a notification, and if that notification is pertinent towards the end use case or your application or your AI model, what have you. So subscriptions are awesome. They're basically notifications. And there's kind of some improvements we're making for FHIR subscriptions in the future.
Thank you. Any other questions for Vivian? There is one more question about merge. Perhaps it's better to discuss later at the roundtable, or maybe for you to respond in the chat.
Yeah.
Yeah, all right. Thank you so much. Let's move forward. Our next speaker is Sonya Huang with Zus Healthcare. Sonya, please introduce yourself and your topic.
Hi, everyone. I'm Sonya from Zus, and I will be talking about something that's more of our particular use case. And actually, this is a really good contrast, I think, to Vivian's presentation, because we are kind of one of the users of the kind of off-the-shelf, open source-ish FHIR offerings. And I also really appreciate the previous two presentations, because I think I relate a ton to Nikolay's experience with search. This topic is about search being very slow, right? And I wish we could talk about all the things that Zus is doing, also in terms of like trying to merge different resources. That's also a very exciting topic, but I'm going to limit this to what my team has been doing, which has been mostly benchmarking performance on search and then trying to find ways to improve it. Because one of our very one of the use cases that we want to satisfy immediately is kind of the patient-facing application. And so today what I'm going to be talking about is like how we benchmarked the search requests, and then what we kind of discovered about, is search even really useful for what our customer-facing apps want, and then sort of how we ended up how we're ending up trying to solve this, which actually is very relevant to the sort of monolithic problem that Vivian just talked about. So for benchmarking, we spent 3 months just writing benchmarks and just benchmarking search requests. I mean, lots of requests, but mainly search. We wanted to, we basically wanted to figure out if our existing FHIR service would scale well if we increase the number of patients on our system. And then we thought that what we would do was like, we would find out some bottlenecks and then we would fix them. And so we went ahead and did that. We use Gatling as our test suite. I know that there are a lot of benchmarking tools out there for FHIR servers. A lot of them are built upon Locust, I think, which is Python based. We selected Gatling mainly because Gatling has a very nice sort of DSL that allows you to control the user, like concurrent user traffic, and then you can ramp it up and down. And then also each user session has a very specific, you can define a session with a certain number of requests, and you can build requests upon what came back previously. And so it's a very good way of simulating actual users. And so our server is, our main FHIR server is built on Smile CDR, which of course is a commercial offering of Happy. Our database is Postgres. And what we built on top of, we chose Smile CDR basically because we could add a whole bunch of customization in terms of access control. Zus has this access control paradigm where we want to allow anyone with a treatment relationship to the patient to see all the data associated with a patient, regardless of where it came from. And then we've also been adding a lot of, we use tags like FHIR meta tags to kind of categorize resources that come in, so we can have different views of your patient data. So you could see, like, if you only want to see your patient data that came from a third party, you can use a tag to see that. Or if you we have an offering called Lens, which is kind of Zus's solution to the whole deduplication, merging of resources. So if you only want to see the Lens view, you can also use tags to see that. So here is just a chart of the benchmark results that we got from running the same the same suite over a long time. And then this is we're using we were generating sort of Cynthia data for patients, and so each patient has 500 to 1,000 resources associated with them. So if you have 10K patients, you basically have like 5 million, I think 5 million to 10 million resources, and at 100K patients, you have 50 to 100 million resources. We of course tried these are all on AWS. So we tried out different sizes of Postgres, and the thing that we were most concerned about was the search time, because our patient facing apps are mostly doing search requests. They're doing some writes, but I think the feedback that we got was that writes, sort of the performance of writes was less concerning than searches, because when you write, like, you submit a form and then the patient kind of expects to wait a little bit. But for searches, they kind of want the application to be pretty snappy. And so we were noticing that at some point when we were at 100K patients, even as we increased the database size, we were not getting a whole lot of benefit on the average search performance. I think, the types of searches that we had we were mixing them up. So we actually had some that were pretty simple. It was just like, all of these are patient oriented searches. So we're already passing the patient ID, but then if we put in some other parameters, like we want encounters at a certain date, or if we want sort of non-patient oriented queries, like, for example, if I'm a provider and then I have a whole bunch of patients in my sample and I want to get all of them with a certain criteria, that was also something we included in the mix. And I think we also tend to use a lot of chain parameters because we want to search on identifiers a lot. So that's the type of searches in our mix that led to this kind of result. So another thing that we kind of learned during this process when we talked to our sort of downstream applications was we were noticing that they did a whole lot of pagination. And one of the reasons our FHIR server would become slower was just because there was so much load on it. So we wanted to understand why people were making so many requests, like particularly pagination, because I think pagination is kind of not a great use of an API. And so it turns out there are, FHIR has these search parameters that allow you to filter down your data, but there are search parameters that did not exist. And we can create custom search parameters sometimes, but sometimes they want things that are just not there. Like, for example, I don't think FHIR allows you to search like a very broad type of OR query. Like I can't search for the date is something or the name is something. And people were writing applications where they wanted that kind of functionality. So what they would do is they would grab all of that resource, paginate through everything, and then run the OR queries locally on the front end. There's also some issues with sort. I think when you try to sort on the name, but patients have like a lot of names. The sort of results tend to be a little bit unpredictable. I think Nikolay also alluded to the fact that like the sort parameters and search parameters maybe should be decoupled because the way they act is a little bit, it's kind of awkward. And so what was happening was we also had applications where they didn't like how the FHIR server sorted things, so they would grab all the resources and then sort them locally. So all of this activity was causing a lot of load on our server. And then again, I said that Zus uses meta tags a lot to sort of classify data. And we had a lot of services where they were searching by tag, which is fine, but they were also searching by not tag. And in our database, this translates into a not in SQL query, and not in is a very inefficient query. So people were also experiencing, there's currently still experiencing a lot of queries where they ask for tag not, and then the request takes like 5 seconds. So we were learning from a lot of our downstream apps that like FHIR search is just very awkward, and they had to do all this work on their end. And so even if we make our searches very, very fast, they still have to do a whole bunch of work. So we were starting to think of how we could solve their problem, like maybe without having them use the REST API, because the REST API maybe isn't the best fit for their use case. So we looked at the GraphQL spec, which GraphQL solves some of their problems. I think one of the things that was difficult about the REST API is, well, I guess one thing is that with GraphQL, you just get the particular fields you want back, so you're not forced to always get the meta and the some of the mandatory fields that are returned. Another thing that our apps were having trouble with was they would use an include query, so they would get like maybe a patient and then include all of their encounters, but then once they get that full response back, they still have to manually relate everything to each other. Whereas in GraphQL, you can just put the includes in the sort of in place, in line. So that was helpful for them. So we were starting to look at GraphQL as a solution. And what we ended up doing is that because GraphQL is like a GraphQL service is something that we could actually kind of build on the side. And then sort of, we wanted to also tailor the GraphQL API experience to better fit our downstream users' needs. And we understand that the FHIR GraphQL schema is still evolving, so we kind of took a little bit of liberties to design our own. For example, we are doing more decoupling of sort and search parameters. So we are building a service called the Fast Query Service. We're inspired by the FHIR GraphQL schema, but we're also making our own changes to satisfy what we think will be better for our users. So a lot of the, we're taking feedback from our downstream users to basically address the pain points that were very salient when they're using the REST API. So this is just the start of us starting to sort of unmonolith our architecture. So we are kind of targeting the read part of this. The Fast Query service right now is a read-only service, and we're imagining that other things will build other services that kind of consume from the same FHIR change stream. And so the FHIR service right now is still the primary ingestion point of all data. We imagine that there might be, for example, analytics use cases where they would benefit from a change stream, and they could have their own traffic, so it's not on the monolithic FHIR service. And we're also starting to look at sort of the ingestion part of it, which I think is very relevant to what Vivian was talking about earlier. So this is just like where we're at. And yeah, I think that's all I have. I have not looked at the chat. Are there any questions?
Thank you, Sonya. Yeah, there are questions. I think not all of them we probably can address right now. So first of all, there are questions. Audience is looking for you to share back. George is asking, will you share back lessons learned with your customized GraphQL scheme so that FHIR can improve the core definitions? Nikolay is asking if you can share performance tests. Martin is asking, will the missing search options parameters missing from the FHIR spec or just from the server implementation? Can you add more about that?
Sure. So I guess on the search parameters, if they're missing from the FHIR spec, you can define your own search parameters in FHIR. So we have been doing that, but there's some functionality that people are asking for where we simply can't find a way for the FHIR spec to support it. For example, there's the ORs that between unrelated parameters. And there's also some very specific ones, like people want to search for, I think it's like medication administrations where the type of the information source is something. And I don't think FHIR has a way to specify that. We couldn't even find a way to do that in FHIR path.
Nikolay is asking, how do you want to implement fast query service?
Where is that?
I mean, what database do you want to use, or why you think you can do it better than Happy?
I didn't talk at all about the fast query service architecture. So we're actually using DynamoDB. We just stick all of the FHIR resources in DynamoDB. The partition key is just the ID of the resource, and then we have other secondary indexes based on the use case of how people want to query. And so right now our primary use case is is patient oriented. So we have the patient we have a universal patient identifier that can be associated with multiple patient resources. So it's like, if we want to deduplicate the patient, we just assign the same identifier. So that is like one of the partition keys for our one of the indexes that we're using. And that turns out to be very fast. And I think one great thing about DynamoDB is if you select a really good partition key, then it's like completely insensitive to the number of patients, because we've been like adding more and more patients and the request times are like, they don't change at all. So that's been the main architectural change that allows the query service to be fast. But it also means that we can only serve a very limited type of use case. And that's why if we want to serve other use cases, we're going to have to build different services off of the same change stream.
What means fast for you, Sonya? So what response is acceptable for you?
So for searches, I think we're still actually trying to improve our search performance. We're hoping to get everything under 100 milliseconds, just not accounting for network speed. And then for sort of for sort of get by ID things, those should be like really 20 milliseconds. And
do you think to share your performance tests with the community so others can try optimize your request?
Yeah, so we can try to package up our Gatling tests. We have a lot of custom like authentication code written in there, but just the core Gatling tests we probably can try to package up.
Yeah, that's very interesting. So I think if we will give this open source tooling to test FHIR servers, that would be nice from real users.
Oh yeah, on the GraphQL schema, I think when we have we're really still all like kind of trying to. It's still work in progress. I think the early results are promising, but when we know more, I think it would probably be good for us to share that with the community. Having a more powerful server. I don't know if that's about the FHIR service, but definitely like that. Throwing money at the infrastructure is always a way to get a little bit better. But I think one thing we were starting to observe with the our happy server was just the structure of the database, I think, was a little bit limiting, because like there's so many indexes, and then it's getting to a point where everything you write just like adds a huge amount of index, and then everything you search is like all coming from the same table. And then the bigger your tables are, the slower the joins are going to be. So we were kind of forecasting bottlenecks in that area.
And sometimes joins just stop working. So at some limit, it just doesn't work at all.
All right. Let's move on, continue this conversation at the roundtable. So thank you, Sonya. And our last speaker for today is Brandon Kowitz, software engineering manager at Microsoft. Brandon, please pick it up from here.
Yeah, thank you. Just checking mic's okay and sharing screen now.
Yeah, you're good.
Nice, cool, thank you. Okay, so the title that I gave my talk was FHIR Data, How Big is Big? And not so descriptive, but the reason that I sort of landed on this was there's a few things that have been going on that I've noticed is, one is that I love, firstly, that there's a big uptake in the industry with the FHIR standard. So definitely in the past few years, the growth and the community has sort of been amazing in that regard. The next one is, there is now starting to be quite a big uptake in the amount of FHIR data being produced, right? And with that, we need to keep up with, I guess, storing that data, both now and sort of well into the future. So, certainly we haven't seen any slowdown, and, people then with these sort of things in mind come to us and they're like, hey, we need to store a lot of health data, or, a lot of FHIR data, or whatever the question is. And the next question I think I would ask back is, well, how big is big? Like, what is big to you? And there seems to be, from what I've noticed, like fairly defined, I guess, categories of, there's a lot of businesses and health orgs that are, maybe big to them is kind of on the lower end of the scale, especially when it's in cloud. But things can definitely sort of ramp up quickly. And we're also like looking at, supporting people through the growth of their company and their products and their businesses, sort of well into the future. So I'm going to keep going on. Next. Okay, so who am I? Yep, so my name is Brendan. I'm a software engineering manager at Microsoft. The products that I work on day to day, so the OSS FHIR server for Azure. So that's the open source code that we have in GitHub. Anyone can download it. You can spin it up in your own Azure subscription. No limits, see exactly what's there, the way that we've implemented everything in .NET. We also have two managed products. So Azure API for FHIR. So that's backed by Cosmos DB, which is the cloud scale document store. And sort of the latter addition to our product family is Health Data Services, which is kind of like a workspace model. So in here, you can provision a FHIR service, which is backed by SQL Server. And you can also add in, IOMT connectors, DICOM services. So it's kind of like bringing the whole like workspace model together to, operate on health data. Okay, so the agenda that I had for today. So you might take today as kind of sort of like, my learnings and observations over the past few years of working with FHIR. Hopefully I can, throw a bit of a light and maybe a different angle on some of the, I guess, patterns and observations that I've had. So the first one, and I think this is not too dissimilar to, the things that have already been talked about today. So, how the different types of access patterns can influence your storage solution. So I will drill into that. How things change as data volume grows. So, that's the question, like, how big is big to you, and how can we support your growth? And sort of, looking to the future, where, I think I'll try to summarize the patterns that I see, to, put my vision, I guess, forward, based on what I know to what sort of more cloud-based native solutions might look like. All right, so I'm using the well-known pillars here. So data access patterns definitely falling into these two categories. So online transaction processing, and I think this is the CAP theorem that's already been discussed today. Not in exactly the right words here, but I think that's pretty much what I've listed. So throughput and latency is important, consistency is important, and availability is important. It may not be all at the same time, but mostly what I hear is that, yes, when we have an online transaction processing REST API, we want all of them as much as possible. The other category, OLAP, so things like analytics, population level queries. In general, latency might not be as important just because of the type of work that you're doing. And these types of things, will then sort of feed, later on into, analytics or machine learning pipelines. So I'm going to drill into this a little bit more. So what uses the OLTP? Primarily, I would say this solution is the FHIR REST APIs. And there's a bunch of applications that sort of fit into this. So applications using smart health information exchanges, silos and aggregators can use this. Should have put an asterisk there. Patient data access APIs, provider directories, kind of the list goes on. So, anytime you are looking for that, online REST API, this by design is your go-to. And then I thought I'd list some of the query patterns. So things that I've noticed, that perform in general well. And in this one, I did put some asterisks because I think this is an important consideration that in general, no matter what the backing data store is, reads are always fast. Like we always know how to get to a record if you knew the ID. So in this case, if it was patient 123, it doesn't matter if that patient was in Cosmos DB or if it was in SQL Server. We always know how to get it, in the minimum possible time. The next one I put pages with the star, so pagination. And I think, we've already mentioned today that at some point, pagination does put some strain on, certain, I guess, data stores. So SQL may eventually have this problem. But what I've noticed with document-based data stores is they, in general, kind of like shard and partition sort of under the covers. So the way that they work in their continuation tokens is they're, basically like moving their ranges forward. So they may not always hit the first partition. And as you kind of move through, they're kind of like looking in, different partitions and therefore kind of like spreading the load out. If you had this case, in this example here, where a patient where the name is Smith, it may not have to try very hard before it can fill up a page of results and return it to you. Selective queries, so SQL-based systems, if this thing is in the index, then it's going to be quite fast to sort of find those results and return them to you. And I don't know if this is surprising or not, but in general, include statements do tend to perform pretty well. And I believe the reason for this is that as long as you have appropriate search criteria that returns in an okay kind of time in the initial search, the included results are generally just linking to a bunch of IDs. So in document-based data stores, we can just read them in. SQL-based data stores, it's more or less just a join based on that primary key. So they generally seem to perform pretty well. What seems to perform slower? Chain searches seems to be across the board in all data stores. And the reason, SQL, it's joins. In document-based data stores, you're kind of forced to do these sub-selects along the chain query until you can kind of like, basically apply those filters either backwards or forwards, depending on the strategy. But it is, it can be quite a lot of work. So it's something to be mindful of, but I'm not, saying that you shouldn't use them because they are incredibly useful. That's why they're in the standard. But it is a consideration. And I put selective queries here again, but this one has an asterisk. So maybe the reason that pagination works well for document-based data stores, if you were just changing data stores to fix all your problems, you may find different problems in the next data store. So for selective queries in document-based data stores, you're looking for one object in potentially billions of items. And the way that they're working is that you may be sending that query in parallel, to hundreds of petitions. So it can kind of be like an incredibly extensive amount of work just to find one thing. And in this case, the example is identifier. So it's not, it's not the primary key. So it's some search index-based thing. Conditional I put here, not because I think it's particularly problematic, but it can be problematic depending on your use case. So if you are designing your system to say, hey, I'm going to import all the backlog of my data using, conditional posts, conditional creates and updates, I guess just remember that conditional is a composite operation. So you're forcing a search before the next operation is applied. We definitely in FHIR, I think, have been evolving faster ways to import data. So definitely consideration there. And again, depending on the data store, counts and sorts can be problematic. So, definitely in document-based data stores, count, you're kind of like forcing all petitions to return a result. Again, that can be, quite a lot of effort. All right, so taking a breath here. So OLAP, a few different takes on this. So we can export a lot of our data from our, I guess, primary OLTP data store with export. In general, it's going to end up in, I guess, in a few different places. So either like a blob storage, a data warehouse, or a data lake. Yes. Okay. Yes. Sounds good. Okay. And then for the query patterns for these, in general, I feel like once you move to like an OLAP-based data store, you're generally not working with the REST API. So you may be looking at schemas in the OLAP data store that are either flattened or denormalized. So, we may choose to sort of flatten the FHIR out into tables or denormalize it. I think I've seen some solutions transforming into things like OMOP, or you might choose like another querying language that's designed, I guess, for FHIR, such as, SQL on FHIR, Databricks, and there's sort of other hierarchical, based querying languages that can be useful as well. And another querying pattern, I guess, is, the export, which can be filtered, or it can be the entire population. And it matters because, maybe filtered, you're looking at, some particular slice that you're interested in, or some particular time segment. Entire population obviously refers to like, I want all of my data there, and it could just be updated with periodic updates. So we do have an example here that we have also in open source from Microsoft. Your SQL backed FHIR data store here, use the export command, goes into some blob storage, and then there's sort of an additional pipeline here that's going to import it into your analytics system. So I wanted to try to put some numbers, moving on to the next segment. I want to try to put some numbers behind like, what does, data sizes mean, and how does that sort of affect scaling with FHIR? So I started off with like, 0 to 1 terabyte. So these are all in ranges. Think of this as a journey. Perhaps in the future, we'll have sort of much bigger numbers here, but in general, I don't think you can sort of escape a lot of the current computing constraints. But, I think 0 to 1 terabyte, I think you have all options on the table. I think you can, definitely pick your favorite, most comfortable solution. And in general, it's probably just going to work. And then I think as you sort of travel on your journey between like, 1 terabyte and 10 terabytes, it's probably achievable just with scale up strategies, more cores, more disks, more CPUs, bigger VMs, all that sort of thing. And you're probably going to be able to achieve, I believe that sort of solution, within that sort of 1 to 10 terabyte range. But I think when things start to get interesting is once you travel up from there, right? So you go from 10 to 50 terabytes. So maybe typical sources here is like a multi-source aggregation, strategy. So here I think indexes and petitioning becomes important, because if you get it wrong, latency is now amplified. I think we just mentioned in the chat, like joins start to break. Things start to become noticeable around these ranges. And also maybe cost becomes a factor. Disks, they're cheap, but they're not free. So the way that things are stored, can become important. And then we can keep traveling up. So, 50 to 100 terabytes. And this is where I think you have more, more things start to become important here as well, right? Import and export speeds are imperative. Partitioning strategies are highly important. You want to start to make sure you've got efficient cost and storage, factored in there, and operational concerns. So backup time, maintenance operations, these become important factors as well. And I just put greater than 100 terabytes because I think by this point, this strategy is probably going to keep carrying you forward, right? 100 terabytes, petabytes. Like this is where I think the strategy very much becomes, there isn't one thing big enough that will fit all of your data. You're looking at a horizontal scale out strategy. So sharding and partitioning strategies are imperative. Your import export speeds are imperative, like having a good way to do that. Transactions and consistency can be more complex, still solvable, but definitely there's more moving parts. And what you ideally want, is constant time backup store. All right, hopefully that's good. I just wanted to highlight here that depending on how you slice it, if we were say importing maybe 5,000 resources a second, it may be okay at some point, that we keep that speed. But once we sort of reach high data sizes, we need to sort of, look at what do we need to sort of keep the constant time. And, there's a lot of stuff that sort of comes into here. Like you might be maxing out like, like the log rates and disk speeds and stuff like that. So, definitely the scale out strategies are important. I wanted to bring this up just as a food for thought, is that raw JSON doesn't necessarily equal stored JSON. And the three examples I have here is, in document data stores, if they're storing JSON, there is a penalty to be paid for the indexes that are created. And it's the same in SQL, but what I've generally noticed in SQL is that with compression and the right types on indexes, where a Boolean is a bit, it's generally sort of leveled out at about 1-to-1. And I guess just as a comparison, things like blob storage are obviously going to store it verbatim. I wanted to put this in here as like a throwback to some of Graham's earlier thoughts when he was discussing, like, should you be storing FHIR in your database as like, like a JSON blob, or should it be a relational schema? And sort of looking at the spec over a few years, he's actually already, like, there's already two schemas defined. So you have the schema of the models, which is, I think, what we all naturally go to. And then you have the search parameter schema. So it redefines the names it's interested in. It redefines the relationship between other search parameters. And really, this is kind of like an extraction and normalization process. So if we took that forward, this is just a proposal, a theory of, where I think sort of cloud first, cloud native solutions sort of might get to in the future, is that, it's sort of optimized, sharded indexes sort of on the front end to sort of make searches as responsive as possible. Things are stored in blob to kind of reduce the size of the indexes. Plus you have efficient, cheap storage. And then the further thing that might do in the future, and I think this is where, things might eventually migrate, is it gives you kind of like, potentially a unified view with analytics. And even if you're sort of starting out here as like, I only want an online transactional processor, I don't need OLAP yet. At some point, you probably need OLAP. So I think sort of having that build on model is going to make a lot of sense. All right, so sorry to go a little bit over and for a couple of dropouts, but hopefully I've been able to sort of, present a couple of ideas and a couple of views on the future here. So yeah, these are the takeaways that I had. So how things change as the data volumes grow. And yeah, thank you for listening.
Thank you, Brandon. Questions for Brandon, please?
Brendan, the metrics you showed with the data load, is it for Cosmos DB or for SQL?
I've chosen some more like hypothetical numbers here, but they are ones that I think are reasonable and achievable at this point. But yeah, I've kind of given a hypothetical scenario, and I just wanted to show the relationship between loading the data in at those speeds and sort of what happens, you know, if you have 100 terabytes of data, that we really kind of need to flip the paradigm on its head to, you know, look more at constant time as opposed to, you know, just waiting.
The question about partitioning and sharding. Do you mean what sort of partitioning do you propose to use? Partition by patient or something else?
Maybe we could actually leave that one for the roundtable there.
Okay.
That's a great question, and there are so many different ways that you could slice at that. So I don't think the one answer works for everyone.
Mm-hmm. And what's the difference between when you mentioned partitioning and sharding? So what do you mean by partitioning and by sharding?
Right. So what I mean by that is that so a shard, you might say conceptualize that as a database, and partitions might exist sort of within that shard. So in the example, I guess in the chat, so maybe if you did petition by sort of like patient IDs or something like that, then you would, you know, I guess be able to petition your search indexes within one physical database, but you may have multiple physical databases.
All right. Again, thanks again. Let's move forward to the roundtable. I think before that, may I ask Health Samurai team to post into the chat the link to the feedback, so it's not going to be missed if somebody will be dropping off earlier. So please do this, give the link to the audience so everybody can provide the feedback, and please provide the feedback about the meetup. It's important. And yeah, let's move on to the roundtable. Nikolay, do you want to set up the roundtable?
Yeah, I will try. So I think the one question in roundtable for everybody. So we start with speakers and then everybody can participate. So what the main challenge, one challenge you see with the scale and performance FHIR, and maybe share possible solution and how standard or new addition to the standard may help with this. Who can start? Okay, I can start. So, let's facilitate a little bit. So I'm concerned about the FHIR search a lot. So as we see, for me, it's one of the most complicated after the profiling and search. It's two complicated pieces to implement. And there is a lot of stuff. And what we see from real experience, and when people understand what SQL on FHIR can do, they quickly switch to SQL on FHIR. Because low-level control, because it provides much more than FHIR search. You can do aggregation, you can do controllable joins and other stuff. So, and for me, it's still the question, yes, how valuable, how really valuable is FHIR search if we see that the real application switching to SQL on FHIR, if possible, or building something additional, like Sonya said, yes, something new, and not using FHIR search. Or what we can do with the FHIR search. Yes, as everybody said, in SQL you have and ors, you have groups, you have aggregation. Yes, you have a control. But the problem of the SQL is it could not be standardized. Yes, we see a lot of dialects of SQL, and that's how it works. Yes, Oracle, Microsoft SQL, Postgres, MySQL, all different.
I think you're spot on with the search, and I think one place that the search is going to hurt us specifically is in merging and aggregating data. So if I want to find two patients with the same identifier, I need to make a search for that identifier.
Yeah.
Maybe I need to do that over more than one FHIR store. Or maybe I look for, and then you get to think about more complicated cases as well, where a patient maybe has 3 identifiers. And now I want to find all of the same resources with all those 3 identifiers. And to properly aggregate those patients into, what represents really a single patient, you start making multiple searches, which just exacerbates that problem even more. And then you want to update all of that data at the end of it too. So yeah, it's poor search performance results in sort of poor throughput for merging and aggregating too.
I think on that point, what I would have said is a big, what's going to hurt us in the long run, or my biggest kind of concern about the future when we think about FHIR at scale, is a little bit of what Martin was talking about, where there are multiple FHIR servers. Right now, we don't have good federated FHIR or kind of implementation of the ability to do search federation across FHIR servers. But there's a lot of use cases beyond just the technical implications of splitting. It makes sense often to split the data, but there might be kind of regulatory reasons to do this. So different countries or different sensitivities, and apps often shouldn't need to understand the underlying implementation of the fact that there are multiple servers. They want a patient and it should return the patient information, but the latency of searching across multiple FHIR servers is pretty significant. There aren't solutions to do kind of referential integrity and patient everything's across multiple FHIR servers. So thinking about federated FHIR and how we can better make solutions for allowing for that kind of scalability in horizontal scalability, not just the vertical scalability, I think is something that's top of mind for scale.
But do you believe that it's possible to do the federated FHIR using different technologies, or you still? So I'm quite skeptical. I think it's possible to do with the one technology, yes. So aggregate the data and make it work. And the main problem is going to be like merge, as we said, like merging in a broad sense, yes, like, because if you have multiple sources, there's a lot of question about duplicates, about how can I trust this source or not.
Yeah, so you would need to do a searches across and then a merge of the search results, which is not, it's going to be too late or return, be too long of a period of time for most applications. And so I think that's a big issue, is the actual results. There are some things that we might see caching of these results make a lot of sense, where we know that these are common federated searches and we just cache those results. But I'll say Google has technology to do federation, but doing that across technologies is a lot more difficult because identifiers aren't necessarily the same. So the UUID isn't necessarily the same across technologies, things like that. And you have to get everyone to do referential integrity to other URLs, which is just inherently going to be a huge kind of roadblock.
But federated FHIR, yeah, it's a really hot topic. So it's related to merge, and when we're getting more and more data, they will be spread around different sources. That's really challenging piece. I don't know. Does anybody have a vision what federated FHIR can be? Maybe Josh, I don't know. Josh, are you with us?
I am. What I don't know that I have is any overarching vision here. I think the challenges of federated FHIR are likely to be more organizational and management in addition to technical. You know, when I think about this in really well-controlled domains outside of healthcare, you know, I could ask questions like this pertaining to my email or to my photo management or to my calendar. And those are domains where the data models have been stable for years and where, you know, in some cases there are standards and there's lots of mature software, and still I don't have those kinds of capabilities. I wouldn't expect that we're going to be able to introduce them in healthcare in some, you know, brand new way that we've never seen anywhere else.
Oh, that's interesting. Maybe on patient level, this is possible, yes?
Oh, for sure. I think that individuals who are able to aggregate their own data from more than one place, or health systems that are interested in exchanging data with many trading partners and bringing together data, will have the advantage of a much more complete picture. But there's real work to do there, right? It might turn out that the challenging deduplication and reconciliation is work that needs to be repeated. maybe the best example I have of this kind of flow is distributed version control, like we see with Git, where the true history and complexity of branching source trees is there. It's well represented. Dealing with merge conflicts is still hard. But if you go through the effort, if you reconcile the conflicts between a set of changes from two remote branches, you can benefit from that reconciliation. And you can also share it back downstream. So other folks can start with your reconciled branch and they understand exactly what the inputs were. So that I'm much more enthusiastic and much more hopeful about, but I don't think we're going to be able to sort of push all that hard work somehow into the network or push it too far away from us. We're going to have to engage in it, and then hopefully we can share the artifacts that we generate from it.
Yeah, that's interesting. Patient record as a Git repo, yeah.
On that thought as well, so something I kind of wanted to ask earlier was about it's related to merge, is what happens when upstream data sources make errors, and they do. They'll put the wrong piece of data in someone's record and they'll send you an update, and if you've merged those records from different providers into one super record, somebody sends a correction, now you have to unpick it, right? Half that FHIR resource came from here, half of it came from there. Which bits came from where? How do I undo that or redo the merge?
Yeah, you're actually diving into like a huge value prop that is extremely difficult to explain to people who haven't actually thought about this in as much depth as what we're getting into, where we will actually delete the entire resource, pull the provenance, understand the IDs, which IDs each HL7 which HL7 messages built that entire FHIR bundle or that entire FHIR record, delete the entire thing and replay each of them with understanding which piece of information was the incorrect piece of information. And you need to do that all with history on, so that if someone made a decision based on the incorrect piece of information, you have an auditing trail of this. And so provenance is really, really important when talking about like replay. We call it kind of rewind and replay, where you rewind back to a previous state in the database and then replay the information with a correct updated piece of information. But it's an extremely difficult and complicated piece of logic and software that has to do that. And it's not something that people think about when trying to kind of implement this stuff. So provenance, I think, is probably the most important answer there, and tracking where each piece of information came from. But it's absolutely a very difficult problem to solve.
Yeah. I think you described code that my colleagues have been writing for the last few months. Trying to find those business rules to how to match things across sources, how to specifically aggregate them, tag which bits came from which source. It's going to be interesting, and something, because it's so complicated, you need room to get it wrong and update it and update your implementation without being stuck with all the data that you can't then change.
I think for the federated FHIR, it's important to track the source of data, yes, and it should be something global. So something global, like, I don't know, blockchain with origins of the resource, so you can track this resource. If you do some changes to this source, they should be stored as well, like conflict-free data types, yes, something like this. So then we can imagine something like federated FHIR, multiple sources.
Yeah, I think sources for federated FHIR is imperative, because you can imagine patient-reported data isn't as trusted as clinician-reported data. So you might want to federate that information so that an application who needs to make a clinical decision isn't basing that decision based off of patient-reported information. But that's really where provenance and lineage tracking is. It's table stakes for anything that's doing kind of transformation and harmonizations to FHIR.
That's also an interesting point about patient data and clinician data having different reliability. And in some cases, that's definitely true. I wouldn't trust a patient to enter their own, I wouldn't trust an average patient to enter their own blood pressure, but to enter their own address, on the other hand, certain amounts of data coming from the patient will be more trustworthy. The business has to kind of make decisions about who do you trust more, and how do you present that?
Yeah, my colleague Paul wrote on the chat a little bit about how, like we call it consent, but understanding the piece of doing some check before you're returning a search bundle. I don't think FHIR has great, what I call kind of like intent of an application, where you understand you want both clinician and patient reported data, or just patient reported data, or just patient reported data that has consent for such. That those kind of checks have to happen when returning a search bundle, and that just adds additional logic and complexities and latency to the whole system, but are really important when you kind of look at production level use cases for this.
I guess this harks back to Sonya's talk earlier, where she said that clients were making requests for all of the data in client-side filtering. I mean, maybe due to those less complete search parameters.
Yeah, the problem that client not always can filter what they want. Yes, because database is huge. You could not get everything.
Well, yeah.
Yeah, maybe join. So that's about the flexibility of the storage, I think. Okay, somebody else? Some other challenge? Or the federated FHIR is the gravity.
Maybe just as a heads up for this group, at the Connectathon last weekend, Graham gave a presentation about architectural options for a very specific flavor of federated FHIR. The idea here being, what does it take to stand up one server that can surface a FHIR API, but under the hood, it's purely just querying some pool of other servers. So maybe you have a national server that can answer questions at the national level, but under the hood, it's calling 5 regional servers to get all the answers. So Graham presented kind of a view about a few different ways you could build a server like that, and they all have their challenges, which would be no surprise to this group. But that's just something to be on the lookout for. I think he's going to put together a white paper kind of laying out some of those design choices and trade-offs. Things like, do you reassign IDs? How do you manage traversal orders for searches? All kinds of fun stuff.
Is that something he's written already? I can go read.
No, well, so he's written.
Heard from him.
He's written a slide deck and an articulation of sort of what these 5 patterns are, but I don't think he's put any kind of narrative flesh behind it.
Do you have a link? I'd love to read that.
I don't, because he just shared it live in the room, but I will ping him on Zulip and see. I expect he'd be willing to share that publicly even before, the white paper exists, because in a large part, it was in response to a long Zulip thread on this topic. He was just kind of rolling up the ideas that he had heard.
Mm-hmm. But you personally, Josh, believe in this or not?
I believe that it can be done in some narrow ways and that it can provide some use, but I think there's going to be pretty hard constraints that will mean it's not suitable for most use cases.
Mm-hmm. So from my point of view, distributing the low-level data, I think that may be the key.
Yeah, I think that will turn out to be far more useful in the long run. But when you think about examples like the things that we talk about in the US as health information exchange, right? I have this patient in the emergency room. I've never seen them before. What query can I run that will help me figure out if anybody knows this person? For that, I could imagine a national centralized service that could answer that sort of question on the basis of querying some small number, on the order of 10 underlying servers that were authoritative in some subdomain. I could imagine that would work. It's not the only approach, but I could see some value there.
Mm-hmm.
Yes, the challenge I see with that is I wonder what the minimum expected availability would be, because I guess it would be the minimum of all the regional servers.
Yeah, so part of the write-up was dealing with those kinds of details. How do you surface information like servers 1 through 9 don't know anybody like Brendan, and server 10 didn't respond?
Right. Yep.
So suddenly you've broken your abstraction barrier, and whoever wrote the query needs to decide whether they care about server 10 or not.
Mhm.
Yep. Yeah. Partial data in, I guess, the health space is, yeah, you need to decide what to do with that.
I can imagine something like blob storage, yes, where the record is saved like Git repo, and some discovery services which allow you to get access to this data, and that you're able to load this data, index, and blah blah blah. So that's my opinion, because the FHIR search, again, for me, it's like 50% failed for real scenarios. So I don't know how you can build the smarter system on top of it. So, but the raw data, it's a real value. Yes, the new databases are coming, the new techniques are coming. So the data is a real gold. And what kind of indexes you can build on top of this data, it's a matter of time, I think, and technology, and they will change quickly. I think now the renaissance of databases, we see that every week the new database appear. Okay. Yeah.
Add one last thing again relating to search. So somebody, sorry, Brian posted very shortly, and security and identity too, and that adds an. And there was a quick earlier discussion about get me all of the observations that I'm allowed to see, which is, you know, it's yet another dimension of search, and one that might be quite complicated based on your access control rules. So if you want to be able to service queries like, please get me all the observations that I'm allowed to see, that's again another place where if you have search performance really matters. Yeah, I think you might be right.
Yeah,
I think search performance might be pretty key.
I think that's where we see some separation of data, where we know, you know, use case A is over here, use case B is over here, because they're always going to be siloed in that kind of a search. But it's really complicated to have the logic for that. You end up with like a chain parameter where if the practitioner is referenced in this patient, then it can be returned. Otherwise, it's not. And that just adds complexity to searches that just it really isn't scalable in a lot of ways. And we call it consent, where you have to check access like that within a consent resource before you actually can return anything. And chaining like that is just difficult.
Yeah, we play it a lot with the consent as well. And this is a joint problem. So yeah, and it's extremely problematic. So what I see, if you want to be efficient, you have to put this data into resource by themselves, if it's possible. So who can see this resource, build index, and then it will work in 10 milliseconds. Otherwise, I don't know, it just doesn't work.
Yeah, I've seen contained resource, because consent and provenance often have like very similar access needs, where I want to only return data from this place or data that has consent. And so containing it can be a way, but that's not really, contained isn't necessarily a great practice for FHIR in general. And so I think we just have to actually figure out how to better do access controls on top of FHIR in general, rather than requiring a search within a resource to return resources.
And consent may be the rule, yes. So you can see only this type of specific observation, then you have to merge your search query with the rules from the consent. Right. And I personally don't like this implicit logic. So we had a meetup about access control. You probably can look into YouTube. It's it was very interesting. So I prefer something more explicit, because sometimes the user may have different roles. So then you should communicate to the server. Now I'm looking as a physician or as a nurse from this department or from this department.
Yeah, we're also having a discussion the other day on like, if you're trying to query resources that you can see, but you may be doing chain queries into resources that, like going through a resource that you weren't allowed to see, you could return results based on, you know, something being there or not. which could potentially be kind of like poking around the corners of, you know, questions you shouldn't have been allowed to know the answer to. So it's a very deep topic for sure. So
I think we actually could have a whole access topic, because we also, when we talk about AI, there's AI models that are returning this patient might have cancer, and they run a patient everything, and they can see it as a condition, but they shouldn't have. And it's like very detrimental for them. And maybe it was a crappy AI model, but we don't actually have ways to limit them from seeing information about themselves in a way that makes sense. And so access is like really complicated when we think about provenance, consent, and some of the inference world we're going into.
I will say there's a couple of important angles to those questions, and it reminds me of e-patient Dave DeBronckart's kind of the first major problem he hit as a patient working with his electronic data was he had billing codes that showed up as diagnoses, right, for a whole bunch of problems he didn't have, but they were problems that maybe at some point somebody ran a test to rule out this problem, and then his patient portal surfaced it in the wrong way. To me, this is not so much an access control decision. Like the right answer wasn't that the information should have been hidden. The right answer is that it should have been surfaced in context. So rather than, you know, you have this diagnosis, there could be a correct assessment of you don't have it, or we ran this test to see if you had it and the answer was no. Or in the case of inferences, you know, this is a very low probability result. That's not part of your problem list, but figuring out the right ways to describe those semantics rather than trying to figure out ways to limit or hide, you know, we might find out that those are going to be useful techniques as well.
Okay, so maybe
sounds like the next conference should be access control.
Maybe this is so we have a lot of people. Maybe there are some questions to the speakers or to somebody in the room.
Hi, everyone. I do have a question, but it's kind of a basic question because our company is like just starting with FHIR, so I don't know if it might be a little bit of an obvious question, but I guess what we're starting to do is to implement a backend using FHIR, and one of the things that I would like to get right from the beginning is like, what's the best way to exchange data? I haven't read a lot like extensively over how to say like the available FHIR resources and all of that, but I guess I wanted to, I guess it also depends on the use case, right? But what is the best way to, or what do you think are the best practices when exchanging data? Because to my understanding, basically, if we have like two FHIR servers and we want to exchange data, like a patient resource has to exist in both places, and then you have to kind of duplicate everything, or like duplicate the things that you want to have. So I guess that was the question. I don't know if there's like a better way to go about it. I know with Smart on FHIR, you can make like applications to just display some of the data instead of having to like send all of the resources to like a different location. But I don't know if you guys maybe have some, I don't know, maybe best practices or some kind of like basic feedback in regards to that.
Okay, guys, can somebody answer the question? So can you give summaries of how to exchange data between two FHIR servers?
I was also wanting to clarify, do we mean exchange or like synchronize, or?
I'm not really sure of like what are the specific ways, but like, yeah, that's already a difference, because you can exchange like specific things and then you can also synchronize. So basically like making sure all of the data is in both places, right?
Right.
Use a subscription to do just this, subscription to all the resources, so you can do it and synchronize it.
Sure, I guess that would also be an option, because not really, like what we're trying to do right now is basically to use IoT devices to generate data and store it into our FHIR server, and then we would be like sharing that to a different FHIR server, and then we might request like how do you call this, like health, different health resources. But I guess it wouldn't be like syncing per se, because I don't think we want all data in both locations. But yeah, I don't know. I guess it's not a very precise question. Yeah.
That's the right problem. I think Gina have something to say. Yes.
Oh, I just realized my camera was off. I was eating lunch earlier and never turned it back on. Yeah, I think, for if you're both systems are FHIR servers, the subscriptions should hopefully be a good mechanism for that and be able to send those back and forth and filter depending on what you need and all of those things. If you're amassing data from IoT devices, it's probably not in FHIR to start with. So then you start getting into the realm of at what point do you convert it to FHIR? And is that part of that synchronization scheme to say, some sort of collection endpoint before it's turned into FHIR, and then that is what's converting it to FHIR and sending it to the FHIR server. It's a pretty broad question with an even broader design space, I think. So it's definitely an interesting discussion, but I don't know that we could time box it and be productive.
Right. They're going to be challenged on the deletes as well, right? Like any record that gets deleted from the other server and the synchronization, right?
Yes, and subscriptions have the topic-based subscriptions have ways to say when anything's deleted or different things like that. So if your FHIR server is doing interactions, you can even have a non-FHIR server that's just getting webhook messages and things like that. So it's pretty flexible in that. And whether they're both FHIR servers or just one is or different things, all those pieces should work.
No, I feel like that's very useful because that's something I didn't think about. Like my idea was just, okay, data is coming in, just send it to the server. But yeah, it's true if a record is deleted for whatever reason, it has to be advertised to like the other server. So that's actually pretty helpful. Thank you so much.
I'd also say you want to think about, are you carrying over ideas from V2 where in order to be able to access the data, you need a copy of it? Or, with FHIR, why not just go query that other server? Why do we need to copy the data?
Right. That's kind of we still have to discuss because we are basically integrating with a different company that has like their own system. So we haven't really gone down into like the nitty-gritty details of like how to what's the best way to do it. But yeah, like querying it would be an option, or if they make like some kind of embeddable dashboard like on their site to get the data and then we don't have to query it, that's also, I guess, a different way to do it. There are like so many different ways of handling it.
Yeah, in theory of distributed systems, something like replication log is a solution, and the topic-based subscription almost provide this.
Yeah, definitely. I think that would be the way to go, at least for the IoT aspect of it, like for sending data, because I was just going to, yeah, as I said, like use some serverless function to like push data and just forget about it.
Mm-hmm. I know, is there a possibility to define the topic which collect all the changes?
Yes.
Mm-hmm. And that's how we can get this replication log. Yes, so everybody can reply and get the changes.
Yeah, and part of that's going to be architecturally, do you want one change feed that has everything? Do you want to separate out so that you have creates, updates, deletes, based on the FHIR interaction model separately, all those kinds of things. Hopefully the plumbing's all there to do all of those kinds of setups, but that'll be architecturally driven.
Definitely. Yeah, I think that kind of answers my question. It wasn't super like specific, so but thank you so much for the feedback because it definitely helps.
Okay, guys, let's do a couple more questions.
I have a question that might not be totally related to what we're talking about, but the relationship between FHIR and OpenAIRE or even EHR. So we're having problems with, right now we're talking about performance, scaling, and all of that. Can these two guys work together to solve that problem rather than, so using FHIR for the mechanism of transferring and the protocol to exchange the data, and OpenAIRE for the data resources and act as a CDR on top?
I even don't know who can try to answer this question. Josh, can you say something about this?
There is in Europe specifically, there is more and more adaptation of OpenAIRE.
Yeah, the OpenAIRE originally started from Europe, yes, but I think they lose the race with the FHIR. So that's my
I'm not talking about losing race, who's better. I'm talking about each one, what it does it better and what does it good.
They do things differently. Yes, there are some very interesting parts in OpenAI. They do things differently. They promise that they can generate thousands of profiles of FHIR. But
Archetypes.
I don't know who can handle these thousands of profiles. So it's like semantic mismatch, I think, between them. So that they both can model each other. Yes. So the OpenAI can create the FHIR model using archetypes. But I still think it's a lot of questions. As I know, the OpenAI doesn't have like a centralized repo of archetypes. Yes, so it's very specific for the applications. They only
actually they do. The archetypes are general for the use case from the clinical data module, and then you translate the archetype to templates, what is specific to it.
Mm-hmm.
I don't know if there's any initiatives to bridge the gap between both or to see how you can use both or anything. That's why I'm asking if any is aware of anything like that.
Yeah, we can try to, as I know, there are OpenAI guys in FHIR community. So I'm not sure about the status of this integration. So I don't know, we can kind of invite these people and make the next meetup with OpenAI and FHIR. There are a lot of interesting stuff in OpenAI, yes. So, but the relationship, I don't know, it's not very clear for me at least. I don't know, Josh, Gina, maybe you know how they related. What there was some work, I remember.
Yeah, I mean, there has been certainly a lot of external analysis from folks on the OpenAI team that have helped to inform both consistency and design in the FHIR world. So that's a meta level answer. You know, at least historically, I would have said that OpenAI is much more concerned with how systems kind of work, how data collection is managed, how interfaces can be built up from these templates. And FHIR was more concerned with how information is communicated from point A to point B, kind of between systems rather than within. But that was a historical view. I see more and more interest in using FHIR as the basis for application internal data modeling. And so I think those assumptions don't really hold so much anymore.
Okay.
But we can try look for the OpenAI guys. Yeah, I remember this post about with the OpenAI critic of FHIR consistency. Do you mean this one, Josh? Yes, when after that Graham introduced patterns.
That's right.
So maybe this meetup can be interesting. So kind of battle style.
Yeah, I'll be looking forward for that.
Okay. You can be part of it. So
I'll try. I'm not an expert, I'm just exploring.
Yeah, so you can have a talk with the problem, not with a solution. Yeah.
Yeah, so the problem statement that I'm trying to solve is having OpenAI actually as a data repository that FHIR is looking at, rather than having our own database created, backed up, FHIR backed up by this database. So that's the thing that I'm looking at right now.
I remember the initiative when they tried to generate the FHIR profiles from archetypes and templates. So I don't know how it's ended, but potentially this may work for you. So you're just serving your archetypes and templates as a FHIR resources.
Yeah, interesting. Okay.
Okay, let's have a last question.
Let me ask about bulk FHIR API, and I mean, probably one of the potential sources of large volumes of FHIR data. What about production use of bulk FHIR API with current HR vendors? Does anybody have experience to share? I mean, talking about 21st.
We did recently host a meeting between the Smart Health IT community and ONC to try to understand some of how these bulk data APIs are being used in production these days. And we heard from some of the EHR vendors who have built support and from some of their customers who are using it. Maybe the first thing to say is in FHIR right now, if you look at the async.html page of the current build, and I'll put a link into the chat, there's a couple of broad definitions that we have for asynchronous processing. And one of those is large scale stuff that we use for bulk exports. That same model can be used for other operations as well. So it's part of the core FHIR specification, because we know there may be other flavors of moving large data sets around that might want to use these same patterns of ND-JSON files and a manifest and so on. So that's a sort of general capability. But in the US, this is a function that certified EHRs need to support by the end of this year in order to export data about a whole group of patients, particularly to export the US core data set for a group of patients. And so we heard from a couple of health systems that are starting to test out these waters. Epic, for example, has already shipped support for group level bulk export. And there are some, so one of the decisions that vendors have to make is whether they want to attach their bulk export functionality to their transactional data store so that everything is kind of up to the minute, or whether they want to attach it to some kind of analytics environment. And that's really up to them in terms of an implementation decision, but it has implications on customers. So if the functionality is part of the transactional store, it could slow down the EHR that customers are using during the day, or they might have to limit the size of exports they can do. So we've seen some systems running bulk export, but only on kind of a backup copy of their database. So it's tied to a transactional data store, but they'll run it in their sort of backup environment or their staging environment to limit some of those kinds of impacts. So it's very interesting seeing early on both some of the limitations and some of the capabilities here. I would say the early experience that we've got is defining groups is one of the big challenges, because the rules just say that the EHRs need to support export about a group. The rules don't say who gets to define a group or how is a group defined. It's assumed that just somehow the group exists. And once the group exists, you can export data about it. And so different vendors are making different decisions there as well. Some are providing, let's say, a proprietary or EHR specific way to create the groups, and then using the FHIR standard to export the data about the groups. Others are looking at using the FHIR group API to actually manage those definitions. So from that perspective, Pavel, I'd say it's still really early days. We've got initial customers sort of out in the marketplace testing out these features, and we would love to take what we've learned and incorporate that back into future releases. So we already put out the bulk data STU2, the second release of that specification based on what we learned last year and the year before. And we want to continue evolving that functionality based on real world issues.
Thank you, Josh. All right, let's wrap it up. Thank you so much for everyone who joined and stayed to the end. Please respond to the feedback form to help us make next meetups and make them better. Special thanks to speakers. Again, I think Vivian dropped, but Sonya, thank you so much. Brandon, Nikolay, pleasure to have you the meetup. Yeah, and everybody have a great rest of your week, evening, day, afternoon, like different time zones online. Yeah, see you soon again. All right.
Thank you, guys.
Thank you.
Bye.
Thanks.
Thanks, everyone.
Cheers.